unary operators can be combined. In our current memory, pointer q stores address b0, and therefore it's pointing to this integer in memory. So let's try to practice a little bit of combination of different unary operators used with the pointer. For example, let's try expression plus plus asterisk q. And of course this is a complete statement. And we need to figure out what exactly is happening as a result. You can see that we are trying to use two unary operators applied to pointer q. First, we have an asterisk. Asterisk is a dereference operator. All unary operators have, at least when they're used on the left-hand side of their operand, are considered to be right to left associated, which means that the compiler will always attempt to apply this operator to an object on the right hand side. So anyways, this becomes evaluated first. So this is the reference of pointer. This pointer is pointing to this integer, and therefore this integer in memory becomes a target of the next operation, which is the increment. In fact, it's a prefix increment operator. So with dereferencing the pointer, it becomes this integer in memory, and we increment this integer, so it becomes 3. So I'd say that numeric value that we're eventually manipulating here is 3. And the data type, since the actual manipulation occurs on an integer, we can just indicate that this is an int, because once pointer is dereferenced, it becomes an integer. Let's try a couple of more similar examples. Number 25. For example, we can try to assign array A0 equals dereference plus plus q. Another cryptic statement. But let's try to take it apart and see what actually happens. So here we have a combination. By the way, we can remove parentheses in the previous sample just to make an observation about the difference between the two. In this case, once again, we have two unary operators applied to a pointer, and because of this right to left associativity, again, this will be happening first. So the first operator, which is right next to the name of the pointer, will be applied. Of course, the pointer will be incremented. So let's indicate that when we increment this pointer, at the beginning it's pointing to this memory location, of course the location of this integer in memory, and if we increment the value, it will be moved to the next integer in memory. That's the result of this increment. So then we can say that the value of the memory location stored by pointer q changes to the new value, which is b4. So this becomes b4. And I just realized that just a few steps ago we updated a2 with the new value, and I forgot to change it on my board right here, so I'll just make this change right now. Sorry about that. So let's go back to our statement right here. So we already incremented the pointer and now we're dereferencing it. So as we dereferencing it, it becomes a value stored in this integer, which is 1, and we're assigning it to location A0. So this will be, the new value here will be 1, and of course I need to update it right here. And as a side effect, I'm specifying here that Q becomes B4. We can also try something similar to this with the post increment or post decrement operator. So let's try a very similar statement that looks like this. And as you can see, here we have both post decrement and a dereference operator.